Now let us understand the segmentation and fragmentation. Okay, so in the previous lecture we have seen the IPv4 header structure, and in the IPv4 header we have one field, and that is named as total length or length of the packet. And that field was of 16 bits. Now टोटल लेंथ या लेंथ ऑफ द पैकेट जो हम पहले डिस्कस भी कर चुके हैं, दैट इज नथिंग बट द टोटल पैकेट साइज विच इंक्लूड्स द नेटवर्क हेडर साइज plus data. So this is what the total length, or you can say length of the packet. So this is what the total length, and we all knows the header size, the actual header size varies from 20 bytes to 60 bytes. Okay, and rest is your data. So यहाँ पे आप देखो कि 16 bits are reserved for the length of packet. That means the maximum the maximum number that could be represented with 16 bit is 2 raised to power 16 minus 1, and that is 65535. Okay, so this is something what the maximum number that could be put in the field of length of packet in the IP header, and that suggests that the packet size that can be maximum possible is 65535. So this is the maximum size of IP datagram. Okay, now let us suppose how this we will see that how this figure is going to solve the problem of segmentation and fragmentation in our case. So let us understand that let's say we have TCP IP protocol, and in the TCP IP we have, let's say, 5 layer: application layer, transport layer, network layer, data link layer, and physical layer. Okay, and we know that at the network layer the maximum length of, or you can say the total length of the packet, or total length, or you can say the size of packet can be 65535, and that is the size of header plus data. So let's say this is the header which network layer has included, and what the remaining payload or the data we can say is nothing but, let's say the maximum can be possible when we will take the minimum size of header, and which is 20 bytes. Okay, then we will have the maximum payload possible, and the maximum payload that can be possible here would be 65535 minus 20 bytes, which is 65515. So this is the maximum payload that can be, that can come to this network layer, okay, from transport layer. So we can say this is the payload that can be transmitted by the maximum payload that can be transmitted by the transport layer. So transport layer can send 65515 maximum payload to network layer, and we know that again we have 20 bytes of data for transport layer also, and hence we have left with 65495 bytes of data, okay, that can be easily put in the transport layer. And at the application layer we have ample amount of data. So it is the responsibility of transport layer जो कि मैसेज को डिवाइड करेगी और इनटू द सेगमेंट्स इन सच ए वे कि एक आपका जो पेलोड आपका यहाँ पे जो बनेगा ट्रांसपोर्ट लेयर पेलोड वो आपका इस तरीके से बने ताकि नेटवर्क लेयर में आपके पास 65535 टोटल साइज से ज़्यादा ना हो. ओके, सो यहाँ पे आप देखेंगे तो मैक्सिमम सेगमेंट साइज कैन बी पॉसिबल विच इज 65495. ओके, सो यहाँ पे that is something कि message, if the message is divided into such a way that is of size 65495, okay, so that could be easily fit in the transport layer. okay, एंड ट्रांसपोर्ट लेयर पे अगर हम बात करें, पहले इसको यहाँ पे देख लेते हैं. एप्लीकेशन लेयर पे हम इस डेटा को बोलते हैं मैसेज. ट्रांसपोर्ट लेयर पे उसका नाम हो जाता है सेगमेंट. नेटवर्क लेयर पे वी कॉल इट डेटाग्राम. डेटा लिंक लेयर पे वही फ्रेम हो जाता है. एंड फिजिकल लिंक लेयर पे वी कॉल इट वन पीडीयू. ओके, सो द थिंग इज कि यहाँ पे आपके पास सेगमेंटेशन किसने किया? ट्रांसपोर्ट लेयर ने सेगमेंटेशन किया. That is, segmentation is something that dividing the message into the segments in such a way that the size of the segment could easily fit in. Okay, and the payload which comes out from the transport layer to the network layer should not exceed the value from 65515, so as the total size of the packet should not exceed 65535, because this 65535 can be the maximum possible values that could be that can be present in the network header, or you can say IPv4 header. okay, सो यहाँ पे आपके पास क्या होता है? सेगमेंटेशन आपका ट्रांसपोर्ट लेयर पे होता है. बट यहाँ पे अगर आप देखें तो हमने डिस्कस किया था डेटा लिंक लेयर में, इफ द डेटा लिंक लेयर इज फॉलोइंग एनी ईथरनेट फ्रेम, सो ईथरनेट फ्रेम में आपके पास जो मैक्सिमम पॉसिबल डेटा है वो आपका हो सकता है 1500 बाइट्स. एंड डेटा लिंक लेयर आपका हेडर और एक टेल इसमें ऐड करेगा. ओके, सो यहाँ पे अगर आप देखें कि मैक्सिमम अमाउंट ऑफ डेटा दैट कैन बी प्रेजेंट एट द डेटा लिंक लेयर इज 1500 बाइट, but what we are receiving from this network layer is something 65535, so that cannot fit in to the data link layer. So for that, data link layer has to do fragmentation. And in the fragmentation, what data link layer, what network layer does, नेटवर्क लेयर आपका क्या करेगा? नेटवर्क लेयर सेगमेंटेशन करता है आपका, और आपके जो पूरा आपका डेटाग्राम है उस डेटाग्राम को डिफरेंट डिफरेंट पीसेज में डिवाइड करता है. उन पीसेज को हम फ्रेगमेंट्स बोलते हैं. सो उन फ्रेगमेंट का साइज आपका 1500 बाइट से एक्सीड नहीं करना चाहिए, बिकॉज वी कैन नॉट पुट द वैल्यू more than 1500 bytes in a data link frame. सो डेटा लिंक लेयर फ्रेम में आप मैक्सिमम 1500 बाइट आपका रख सकते हैं. दैट मीन्स यहाँ पे, और व्हाट इज अ फ्रेमिंग? फ्रेमिंग इज नथिंग बट जब इस डेटा के ऊपर आप डेटा लिंक लेयर आपका हेडर और टेल ऐड करती है, सो दैट इज वी कॉल्ड एज फ्रेमिंग. सो हेयर द क्वेश्चन इज कि यहाँ पे वी हैव एम्पल साइज ऑफ डेटा. ओके, and just to fit in into the transport layer, okay, easily we have to segment it. okay, and we have to do segmentation. एंड आपके पास जो नेटवर्क लेयर पे डेटा आपको रिसीव हुआ है, नेटवर्क लेयर को आपको जब आप डेटा लिंक लेयर पे दे देंगे, सो डेटा लिंक लेयर पे आपका साइज मैक्सिमम 1500 बाइट है. तो इसमें फिट इन होने के लिए नेटवर्क लेयर को क्या करना पड़ेगा? फ्रेगमेंटेशन करना होगा. दैट इज, आपके पास जो डेटाग्राम आपको है, आपका डेटाग्राम को उसको डिवाइड करना होगा इन सच ए वे, इनटू द फ्रेगमेंट्स इन सच ए वे कि वो 1500 बाइट से एक्सीड ना करे. So at the application layer, we have ample size of data. Then we have larger size at transport layer, okay, into the segment. Then in network layer पे आपके पास अगर हम देखें, so अगर यहाँ पे हम देखें the size of data को, तो bottleneck जो आपकी हो सकती है वो fragment यहाँ पे network layer पे possible है, okay. And for the bottleneck happening at the network layer, the transport layer has to do the segmentation, and for the bottleneck happening at the data link layer, the network layer has to do the fragmentation, okay. Now there is one thing that अगर ट्रांसपोर्ट लेयर को इस केवल नेटवर्क लेयर के साथ साथ डेटा लिंक लेयर के साइज की भी इंफॉर्मेशन अगर हो, तो सेगमेंटेशन कैन बी डन इन अ वाइज मैनर, और सेगमेंटेशन को आप और अच्छे तरीके से कर सकते हैं। इसको थोड़ा सा इस तरीके से देखिए। So we know that, or you can say the transport layer. If we assume that transport layer know the maximum size that can be possible in the data link layer, and that is as of now 1500 byte. Though it can be vary from LAN to LAN, it is not fixed to the 1500 byte. It may vary from LAN to LAN, and nowadays the this size is also going to be increased. So, but to discuss the concept, I'm taking the same Ethernet frame structure. Okay. So let us suppose the transport layer know the size, maximum size that can be put into the data link layer frame. Let's say this is header and this is tail, and this is the 1500 byte that can be possibly, or that can be easily put in to a frame of data link layer. इसको जो मैक्सिमम आपके पास डेटा आपका यहाँ हो सकता है, पॉसिबल हो सकता है एक फ्रेम में, इसको हम क्या बोलते हैं, MTU बोलते हैं, and that is maximum transmittable unit, okay. So MTU आपका क्या है, MTU is nothing but the maximum data that can be possible in the frame of data link layer, okay. So mind it, the definition of MTU क्या है आपका, maximum data that can be possibly fit into a data link layer frame. That is what the MTU is. So in our case, the MTU is 1500 bytes. So this payload is being received by the network layer, and hence we can say at the network layer, we can have maximum of 1500 byte that can be transmit, and out of it we have 20 bytes of network header or IPv4 header, and rest is what your data is. So maximum data that can be present at the datagram would be 480 bytes, oh sorry, 1480 bytes, okay. And this is the payload of transport layer. So at the transport layer we have maximum payload that can be transferred is from the transport layer, that can be maximum payload can be 1480, and out of that 1480 bytes we have 20 bytes of header, and that is 1460 byte that can be the size of the message should be divided into. So if at the application layer we have the ample of message, so this message should be divided into a size of 1460 bytes chunk, okay. Then one by one this can be fit into the segment of transport layer by adding 20 bytes to it. This payload is being given to the network layer, and the total payload is now 1480 bytes, and after adding 20 bytes to it we will have the 1500 bytes payload that will be given to the data link layer, and data link layer, at the data link layer the payload is 1500 bytes, and that can be the MTU of data link layer, or we can say that data link layer can easily fit this size of data. So the thing is, अगर ट्रांसपोर्ट लेयर पे सेगमेंटेशन वाइजली किया गया है, वाइजली से मतलब है अगर सेगमेंटेशन करते टाइम ट्रांसपोर्ट लेयर कंसीडर करता है नेटवर्क लेयर के साइज को और ट्रांसपोर्ट सॉरी डेटा लिंक लेयर साइज को, मैक्सिमम साइज को, अगर दोनों को कंसीडर करके चलता है तो उस केस में आपको यहाँ पे फ्रेगमेंटेशन करने की कोई ज़रूरत नहीं है. So there is no requirement of fragmentation then, because here सेगमेंटेशन अगर सही से किया गया है, सो यहाँ पे फर्दर इस जो आपके पास डेटाग्राम यहाँ पे रिसीव हुआ है, डेटाग्राम को आपको फर्दर फ्रेगमेंट्स में डिवाइड करने की ज़रूरत नहीं है. और इसीलिए एक सोर्स के ऊपर हम बात करें या किसी होस्ट की बात करें तो वो वहाँ पे आपके पास केवल और केवल सेगमेंटेशन होता है, फ्रेगमेंटेशन नहीं होता है, बिकॉज द सेगमेंटेशन इज बीइंग डन वाइजली by the machine or by the host, okay, in such a way that it cater the size of data link layer, maximum transfer MTU of data link layer into consideration, and hence there is no need of fragmentation at a at end user, or you can say at any host, okay. So the question is, now if there is no requirement of fragmentation, then where the fragmentation is being done, okay. So let us see where fragmentation is done. So let us discuss fragmentation in detail. So ये तो हम देख चुके हैं कि किसी भी होस्ट पे आपका सेगमेंटेशन होगा, फ्रेगमेंटेशन नहीं होगा. तो फ्रेगमेंटेशन कहाँ पर होगा, ओके इसको हम आगे समझते हैं. उससे पहले कुछ पॉइंट्स नोट कर लेते हैं फ्रेगमेंटेशन के बारे में. सो नंबर 1 इज एवरी नेटवर्क has its own MTU. MTU we have already discussed, and MTU is nothing but maximum transmittable unit. Okay, and second is frame does not fragmented, but the packets or datagrams are fragmented. Frames doesn't fragment, but datagrams are fragmented. And third is the fragmentation is done at network layer. And last point is the router takes the responsibility of fragmented packet or fragmented datagram, and not the bridges and switches, because bridges and switches are actually working devices on data link layer. So routers are going to fragment the datagram, not bridges and switches. Okay, so these are the few points that I wanted to discuss before we discuss the fragmentation. Now we will discuss the fragmentation by an example. So let us assume we have one network. Let's say it is a network 802.5, which is a token ring, okay, and there is a host, and let's say the MTU, I assume that MTU is 2000 bytes. Okay, because we have the limitation of MTU at the Ethernet, that is 1500 byte, but for token ring we can have any MTU, and I assume here that the MTU is 2000 bytes. Now by mean of MTU, that means at the data link layer, maximum data that can be fit in is 2000 bytes, and this is the tail of data frame, data link layer frame, and this is the header of data link layer frame. This 2000 byte means that is coming from the network layer of this host, and out of it we have 20 bytes of data, and that is 980 byte of 20 bytes of header and 980 bytes of data. Okay, so this is the structure at this network. Let's say this network is connected to a router, and this router is connected with another network. Let's say this network is the Ethernet network 802.3. Okay, these are the IEEE notations. Okay, so this is the this is network 2, okay, which is an Ethernet network, and that is the MTU is 1500 bytes. Now by mean of 1500, that means the data link layer here can carry maximum of 1500 bytes, and hence the size of the datagram can be 1500 bytes only, and out of it we have 20 bytes of header and we have 480 bytes of data. In the network 1 802.5 we have data size 1980, while in case of the network 2, let's say this is network 2, this is the network 1. सो यहाँ पे आपके पास मैक्सिमम जो आपका जो डेटा है वो 1500 बाइट हो सकता है, आपका एमटीयू जो है वो 1500 बाइट है, यहाँ पे आपका 2000 बाइट है. सो यहाँ पे अगर हम डेटाग्राम के लेवल पे बात करें तो डेटाग्राम में जो आपका डेटा का साइज है वो इस नेटवर्क 1 में 980 बाइट्स हो सकता है, एंड द हेयर इन द नेटवर्क 2 द डेटाग्राम में जो डेटा का साइज है वो आपका 1480 बाइट्स हो सकता है. That means when a packet of size 1980, or you can say in total 2000 बाइट का डेटा जब आपका यहाँ राउटर के इस इंटरफेस पे आएगा, लेट्स से दिस इज इंटरफेस 1, दिस इज इंटरफेस 2. एवरी इंटरफेस हैज 3 लेयर स्ट्रक्चर. ओके, सो राउटर पे जब हम बात करते हैं कि राउटर वर्क्स ऑन 3 लेयर विच इज फिजिकल लेयर, डेटा लिंक लेयर एंड नेटवर्क लेयर. सो दैट मीन्स कि एवरी इंटरफेस जो भी राउटर से कनेक्ट है उसकी अपनी खुद की 3 लेयर्स होंगी. सो लेट्स से दिस इज द राउटर 1. ओके, सो इस इंटरफेस पे जब डेटा रिसीव होगा तो वो आपका ये डेटा आपका रिसीव हो रहा है. ओके, एंड now when this packet or this data frame is trying to when the router is trying to send this packet to the network 2, he will see that the maximum transmittable unit is 1500 byte. So he has to divide this datagram in such a way that the max that the this should not exceed, the size should not exceed the 1500 bytes. Okay, that means at the datagram level it has to convert, it has to fragment the data or fragment the datagram. Okay, in such a way कि आपका जो मैक्सिमम साइज है वो 1500 बाइट से एक्सीड ना करे. नाउ द थिंग इज this 1918 is the 1980 is the size of data that is received, and that can be transmit over here would be 1480 maximum. So that means maximum 1480 size can be we can divide it into such way. Now when network layer will send the datagram of 9080, and we have to divide it in such a way that maximum that can be possible is 1480. Okay, and by including 20 bytes of header, that will have the size 1500 bytes, and that is acceptable. So how much data is left? That is 1980 minus 1480, which is 500. Okay, so we can have another fragment with size 500 bytes, and with 20 bytes of header will be attached. Okay, and the size will become 520 bytes. Okay, so now this is how this would be your fragment 1, this would be your fragment 2. Okay, so this is how we have to divide the data in such a way that maximum data should not exceed the 1500 bytes. Okay, so here if we look carefully, so this would be the size of your size of here this is the size of your one fragment, and this is the size of another fragment. So we can see the total size is coming out to be 1500 plus 520, that is 2020 bytes, and we have 2000 bytes, sorry, we have 2000 bytes here. Now the size of 20 byte is being increased over here, and that size is being increased because we have to add one more header over here. For one header is already added over here, but now for every fragment we have to add one extra header, so that would be the overhead. So here the overhead is coming out to be 20 bytes. Okay, now the thing is, let us take one more example to understand this. Okay, let's say, okay, before going to next example, let's say what happens. Let's say this packet is sent to the next router, and next router is connected with a network. Let's say 802.4, and I suppose that the MTU of this network is infinite, or you can say any amount of data can be fit into the data link frame. Okay, so what happens in this case? Now these two fragments are going to send from this network. One is of 1500 byte and another is of 520 bytes. That includes the 20 byte header here and 20 byte header here. So what happens when it is going to send to the next network, and the next network is having the larger MTU than the previous one? So in that case, there are two choices. Either they can combine, there are two approaches. Either they can combine the packet and make one packet. Okay, so that is what I'm trying to say. So from network 2, so let's say this was network 2, एंड नेटवर्क 2 का जो MTU था वो आपका 1500 था, और इसकी वजह से हमें जो यहाँ पे फ्रेगमेंट करना पड़ा, फ्रेगमेंटेशन करना पड़ा, फ्रेगमेंटेशन करने की वजह से वी हैव गॉट टू फ्रेगमेंट्स and the size of fragment is 520 bytes, and here it is 1500 bytes. Okay, now let's suppose we have another network connected to the next router, that is the router 2, and this network is network 3, and which is let's suppose it's a token bus, so which is having MTU of infinite. Okay, in that case there are two approaches, because now this network can carry the large amount of data than this. So there are two approaches. One approach is either router can combine the fragments and make one packet or one datagram, and another approach is it do not combine and passes the datagram or fragments as it is. Okay, so this is the basic thing about the fragmentation. Let us take one more example to understand this. So let's say we have network 1, and which is having MTU of let's suppose it is having an MTU of 520, is connected to router, and then let's say another network which is having MTU of 200. So what actually happens, that's just because the MTU size in this network is 520, that means the maximum data that can carry a data link layer is 520. That is nothing but the payload of the network layer, and out of it 20 byte of header would be there, so 500 byte of data in the datagram, IP datagram. Okay, now when we are going to send the datagram from this network to the router knows that the other network cannot receive the maximum size of the 500 byte of data, or 520 bytes of data, because it has the MTU size 200. So it can carry, it is 200 byte over here. This is header and tail. Now this can be 20 byte header and 180 byte of data. So that means this 500 bytes should be divided in maximum of 180 data. So one fragment can be 180 20, maximum MTU is 200 now. Then further, how much data we are left with? Again we can have 180, okay, and 20 byte of header will be attached. So maximum 200 MTU will be here. And then how much we are left with? As of now 360 bytes of data is being given, so we are left with 140 bytes of data, and 20 bytes of header will be attached. So uh, how would be, yeah, so you can see that there are these three fragments will receive by the network 2. Okay, and here if you look at the overall data size, what is being transmitted over here, which was 520 bytes. Okay, and here what is being received is this is 500 plus 20 20 20, that is 560. So you can see the overhead which comes out to be 40 bytes. ओके नाउ द थिंग इज कि ये फ्रेगमेंट्स में तो कर दिए, लेकिन रिसीवर को कैसे पता लगेगा कि ये फ्रेगमेंट्स जो हैं वो एक ही डेटाग्राम के फ्रेगमेंट हैं. ओके, बिकॉज रिसीवर के पास तो कई सारे फ्रेगमेंट्स रिसीव होंगे. ओके, फ्रॉम डिफरेंट डिफरेंट पाथ ही विल रिसीव डिफरेंट डिफरेंट फ्रेगमेंट्स. नाउ रिसीवर एंड पे इन फ्रेगमेंट्स को कंबाइन करना होगा, और उनको कंबाइन करने से पहले रिसीवर को ये पता होना चाहिए कि कौन से फ्रेगमेंट किस डेटाग्राम को बिलोंग करते हैं। सो उसको किस तरीके से हम फाइंड आउट करते हैं। एंड हेयर द आईपी हेडर की जो आपकी IPv4 हेडर की सेकंड जो आपकी रो थी, यहाँ वो पिक्चर में आती है, दैट इज द आइडेंटिफिकेशन नंबर, मोर फ्रेगमेंट फील्ड, डोंट फ्रेगमेंट फील्ड। यहाँ पे हम उसको उनको डिस्कस करते हैं, ठीक है। सो लेट अस से वी हैव डिस्कस दैट रिसीवर को क्या करना होगा, रिसीवर को इन फ्रेगमेंट्स को कंबाइन करना होगा, ओके। और टू कंबाइन ऑल दीज फ्रेगमेंट, receiver must know that they belong to the same datagram, okay. That means we need the field, and hence we need the field identification number. So let me draw it again. Let's say this was something, and this was having MTU 520, this was having MTU 200. I'm taking the same example, okay. So here this was 20 and 500. So this is what the datagram is, okay. That is going to send to the router, and router is going to fragment into three parts, and those were 20 bytes of header at every fragment, and maximum can be 200, so 180 can be data, 180, and we are left with 140. So this is how this 500 is divided into 180, 180 and 140. So as I told you that to identify that all these fragments belong to the same datagram, we have this identification number, and this identification number is same as the identification number of the parent or जो आपका datagram था actual. So let's say the identification number here is 100. सो जब फ्रेगमेंटेशन होगा तो फ्रेगमेंटेशन के बाद इनका भी आईडी नंबर आपका क्या होगा, 100 होगा, ओके, बिकॉज दे बिलोंग टू द डेटाग्राम ऑफ आईडी 100. नाउ let's say as we are using the datagram service, in the datagram service what actually happens, हो सकता है कि ये फ्रेगमेंट वन किसी और पाथ को फॉलो करे, सेकंड फ्रेगमेंट किसी और पाथ को फॉलो करे, और हो सकता है पहले ये फ्रेगमेंट आपका अगर शॉर्टेस्ट पाथ पे गया है तो हो सकता है रिसीवर के पास ये फ्रेगमेंट पहले पहुंच जाए, ओके। सो केवल और केवल ये आइडेंटिफाई करने से काम नहीं चलेगा कि ये सारे के सारे डेटा जो फ्रेगमेंट्स हैं वो एक डेटाग्राम के हैं, बल्कि साथ में हमें ये भी आइडेंटिफाई करना होगा कि इनका सीक्वेंस क्या है। एंड टू फॉलो द सीक्वेंस, ये सीक्वेंस पता करने के लिए वी हैव अनदर फील्ड विच इज द ऑफसेट फील्ड। सो आई होप फ्रेगमेंट ऑफसेट फील्ड क्यों हमें ज़रूरत पड़ी, मैं फिर से रिपीट करता हूँ। या फ्रेगमेंट ऑफसेट की हमें ज़रूरत इसलिए पड़ी क्योंकि ऐसा हो सकता है कि ये पैकेट ये आपका जो फ्रेगमेंट है दिस में फॉलो सम राउटर, ओके, टू दिस पाथ टू डेस्टिनेशन, ओके। लेट्स से दिस इज द रिसीवर, और हो सकता है यहाँ पे ये किसी और पाथ को फॉलो करके आ रहा हो, and this is again having passing through another network, okay, and then it is coming out, okay. So if it is something like that, so उस केस में आपके पास क्या है, इट इज़ पॉसिबली कि आपके पास फ्रेगमेंट यहाँ रिसीवर एंड पे आउट ऑफ ऑर्डर मिले, मतलब कि हो सकता है जो बाद वाला फ्रेगमेंट है वो पहले मिल जाए और पहले वाला फ्रेगमेंट बाद में रिसीव हो। So by just looking at the identification number, we cannot identify the sequence of the fragments. But to combine at the receiver end, the receiver must need to know the sequence कि किस सीक्वेंस में ये फ्रेगमेंट हैं। सो फॉर एग्जांपल दिस इज द फर्स्ट फ्रेगमेंट, दिस इज सेकंड फ्रेगमेंट, दिस इज थर्ड फ्रेगमेंट। So at the receiver end, receiver must know that this is the first fragment, this is second fragment, and this is third fragment. And for that we have the field offset. So now what can be the value of offset? So if you simple provide a sequence number, like let's say we provide a sequence number like 0 to for this first fragment, then 1 to the next, and then 2 for the next fragment. So hence you can see over here, एक बार को आपको ऐसा लग रहा है कि यहाँ पे if we provide the offset number like this will suffice. We will talk about it later, but before that one more field we will talk about, that is more fragment field. Okay, so this is one more flag that is again there in IP header, and more fragment tells about whether further there are any fragments following to this fragment, current fragment. So उसके according इसको true or false set किया जाता है. So for example, if we talk about this fragment, whether there are other fragments following this, yes, there are other fragments following this, so MF value is equal to 1. Similarly, for this fragment, whether other fragments are following, yes, so we will set the value 1 over here. And for this, is there any fragment following this fragment? No. So the MF value will be set as 0. So this MF will try to find out when is the end of the fragments. Okay, so there must be a last fragment. So MF field से ये पता लगता है कि last fragment मेरा कौन सा है. सो आईडी से पहली बात तो ये पता लग गया कि एक ही फ्रेगमेंट मतलब कौन कौन से फ्रेगमेंट एक ही सेट को बिलोंग करते हैं या एक ही डेटाग्राम को बिलोंग करते हैं. सेकंड, एमएफ फील्ड से पता लग रहा है कि कौन सा मेरा लास्ट फ्रेगमेंट है, मुझे लास्ट फ्रेगमेंट रिसीव हुआ भी है या नहीं है. सो until unless he will receive the mf set as 0 in the fragment, so he will wait for before combining. So this mf field is very much necessary to find out whether we have received the last fragment of this datagram or not. Now I'm coming to this offset part. So as of now, it is seen that if we mark offset as a sequence number like this 0 1 2, so it is possibly when the receiver will receive the first fragment which is having 0 offset, then it will combine it with the next which is having 1 as offset, then it will combine with next which is having 2 as offset value. So as of now it seems okay, but now the question is, let us suppose मैंने जैसा बताया कि डेटाग्राम में आपके पास जो आपके जितने भी फ्रेगमेंट्स हैं वो डिफरेंट डिफरेंट पाथ को फॉलो कर सकते हैं, और यहाँ पे रिसीवर के पास आउट ऑफ ऑर्डर डिलीवरी हो सकती है. Now let us suppose this second segment. Okay, let's suppose this second segment is taking this path. Okay, and here it is coming to this network. Let us suppose this network has an MTU 100. Okay, that means maximum maximum data that can be put into the data link layer frame in this network will be 100, and hence it can be divided into 20 byte of header and 80 byte of data. And how much data we are left? We are left with 100. So again one more, it would be 20 byte of header and 80 byte of data. So as of now we have received 80 plus 80 160, and we are left with 20. So the third part is or let me write it in this manner. Let us say, so this first is having 80 bytes of data, second is having 80 byte of data, and third is having, we are left with 20 bytes. Okay, so now again you will see identification number is going to be the same because it is the part of this is the parent, and it is part of the same datagram. So the identification number is going to be 100 for all. Similarly, अगर हम बात करें offset की, so now what should be the offset over here? Again, if we mark 0 1 and 2 here, so you can see that when receiver is going to receive every fragments, रिसीवर विल गेट कंफ्यूज कि जीरो ऑफसेट का आपका पास ये फ्रेगमेंट भी है और जीरो ऑफसेट का आपका फ्रेगमेंट ये भी है. With one offset we have fragment this one also, we have this one also. With two offset we have this one also, and we have this one also. So again, he cannot be here. The receiver is not able to sequence it properly. So one thing is clear that this sequence method in the offset is not going to work. So what should be the offset in such manner, या offset किस तरीके से calculate किया जाना चाहिए उसको देखते हैं. उससे पहले एक बार हम यहाँ पे MF को देख लेते हैं. What would be the more fragment field? So in the more fragment, are more fragment following this? Yes, there are more fragment following this. So the MF field is 1. Here also, whether more fragments are following this. So yes, so MF field is going to 1. How about this? Is there any fragment following this? So as of now, you might see that there is no fragment follow. Okay, and you can set, you may set value MF is equal to 0, but it is not correct because this is these fragments are, these are refragmented of a fragment this, and this parent fragment is being followed by another fragment. So hence we can say when we have divided this fragment into further refragmented, that means the last fragment in this fragment is going to follow by another fragment. So we can say that this MF field is equal to 1 because more fragments are following. Okay, so you have to keep in mind that here it is not 0, it would be 1. और यू कैन से द लास्ट फ्रेगमेंट, इसका जो लास्ट फ्रेगमेंट होगा उसकी एम एफ वैल्यू वही होगी जो कि एम एफ वैल्यू आपकी इसके पेरेंट फ्रेगमेंट की है. ओके, लेट अस सपोज इफ द यहाँ पे अगर हम बात करें कि अगर ये फर्दर फ्रेगमेंट होता है, रीफ्रेगमेंट होता है, ये लास्ट वाला फ्रेगमेंट. ओके, ये लास्ट फ्रेगमेंट अगर रीफ्रेगमेंट होगा, so in this case what is happening in this case, let's suppose again it is being transferred to an further network, and which is having, let's say, MTU same 100, I take it. Okay, एंड यू कैन से अगर ये होता है लास्ट में तो इसको भी फर्दर इसी तरीके से डिवाइड होगा, रीफ्रेगमेंट किया जाएगा, एंड दैट वुड बी 20 byte of header, 80 byte of data, and we are left with in total no, not sorry, here it is 140 byte of data. So we have already calculated 80, and here it would be 60. Okay, so this is how it is going to refragment. Okay, and you can see over here, this fragment can be possibly fit in because the size is 100, and here MTU is 100, and here the size of datagram or fragment is 80, and the MTU size is 100. So this is also possible. Now if we talk about the ID is going to be same 100. Offset, as of now I'm not talking about over here, but if I'm talking about the more fragment field, so are more fragment following this? Yes, more fragment are following this, so MF field is going to be 1. How about this? Are more fragment following this? So this is the last fragment of this this last fragment over here, and there are no more fragments are following. So here the MF value will be 0, or you can say, in other word, you can say the last fragment in the refragmentation MF value is going to be the same as the MF value of the parent. Okay, so this is what I'm trying to I'm trying to make you understand that this is how MF field is going to set. Now coming to the offset part, we will see how what would be the scalable offset, because as of now we have seen that this is not going to be scalable. If it is further going to refragment, then there would be a problem at the receiver end. So we cannot set the value of offset as a sequence number. Okay, so now we will see what should be the offset value. Offset value हमारी क्या होनी चाहिए ताकि ये scalable हमें एक solution मिल सके. Okay, so we have seen in the offset part that this is not scalable, just because if as we have seen in this example, जब ये दोबारा से fragment किया गया सो यहाँ पे भी अगर हम सीक्वेंस नंबर रखेंगे तो 0 1 2 हमारे पास सीक्वेंस नंबर मिलेंगे, और उस दैट विल क्रिएट ए प्रॉब्लम एट द रिसीवर एंड, बिकॉज रिसीवर विल गेट more than one fragment with the same offset value. ओके, सो सीक्वेंस नंबर उसको समझ में नहीं आएगा और वो उसको इन ऑर्डर उसको नहीं लगा पाएगा. नाउ क्या कर सकते हैं इसके लिए हम, कैन वी डू समथिंग लाइक दिस, बिकॉज दिस फ्रेगमेंट इज रीफ्रेगमेंटेड अगेन. ओके, एंड दिस वाज हैविंग ऑफसेट वैल्यू 1, so can we have something like this 1.0? Can we have something like this 1.0, 1.1, 1.2? Can we have like this? We cannot, because again we will have a situation like we will have the decimal value and we have to put these decimal value into the fixed set number. So that is not we cannot do that. So that means this kind of solution is also not work, does not work. So उस केस में हम क्या करेंगे? So what we have to do, we will go now by the definition of offset, and that is we have to count the number of data bytes ahead of the current fragment. So for example, अगर मुझे इस fragment का offset calculate करना है, so I have to calculate the number of bytes ahead of this. So as of now you can see there is no data byte, okay, ahead of this. Mind it, we have to calculate only the data bytes. So there is no data byte which is ahead of this fragment. So इसलिए यहाँ पे ऑफसेट वैल्यू आपकी क्या आ जाएगी? 0 आ जाएगी. Similarly, if we want to calculate the offset value for this fragment, so you can see there are how many number of bytes ahead of this. So we have seen 180 bytes are ahead of this, so we can write 180 as offset for this. Similarly, for this fragment, how many data bytes ahead of this? These are 180 and 180, total 360. So we can do like this. Now if this fragment is further refragmented, so what will happen in this case, you can see now how many data bytes ahead of this fragment. You can see this is the first refragment of this fragment, और इस fragment को आपने 3 पार्ट्स में डिवाइड किया है ना. यहाँ पे आप देखिए रीफ्रेगमेंट जो आपने किया है तो 3 फ्रेगमेंट्स फर्दर इसके बने हैं. सो यू कैन सी इसका जो फर्स्ट फ्रेगमेंट होगा उससे कितने बाइट आगे हैं, उससे कितने बाइट और आगे जा चुके हैं, एंड दैट इज 180. और यू कैन सिंपली कैलकुलेट फ्रॉम हेयर that offset value will of the refragment first fragment of the refragmented fragment. उस केस में that would be similar to this the parent fragment, so that would be 180. Okay, you can I hope you can understand this, because 180 bytes are ahead of this. So इसका जो पहले फ्रेगमेंट होगा, इसका जो फर्दर आपने जब रिफ्रेगमेंट किया है इसको, so जो पहला फ्रेगमेंट होगा उससे भी आगे कितनी ये वाली 180 बाइट उससे ahead में होंगी. So इसलिए इसका भी ऑफसेट वैल्यू आपका कितना आएगा? 180 होगा. And now if you want to calculate the offset value for this, and that would be how many 180 bytes are ahead of this, okay, and then 80 bytes more. Okay, so 180 plus 80 is 260 bytes. Okay, and for this इसके इस फ्रेगमेंट के लिए अगर ऑफसेट वैल्यू कैलकुलेट करने चलें तो 180 are ahead of this, and then 80, and then further 80. So 180 plus 160, and that would be 180 plus 160 is 340. So the offset value for this fragment would be 340. Similarly, you can see when this last fragment, if it is further refragmented over here, you can see now the first fragment will get the same value offset, which is the parent, and that is 360, and the value of offset for this fragment would be 360 plus 80. So that would be 440. Okay, so now you can see that you know 440 bytes are ahead of this last fragment, and this fragment is having 60 byte of data. So 440 plus 60 is 500. So we have sent the 500 data bytes, and we have here we can confirm that we have received in total 500 data bytes. So this is correct. नाउ यहाँ पे क्वेश्चन ये है कि क्या ये कंप्लीट है, इज इट द फाइनल सॉल्यूशन फॉर दिस, और बाकी की और वैल्यूज़ क्या होंगी नेटवर्क हेडर में अगर हम कैलकुलेट करने चलें। तो पहले उनको देखते हैं। मान लीजिए अभी क्वेश्चन यहाँ पे है कि to calculate the offset value, we must know the data value or data bytes inside the header, inside the fragment. So fragment में कितना data byte है ये कैसे calculate करेंगे? That is a question. Now I can see here that directly it is 180, it is 180, it is 140. So I can directly see here. But how the router is going to do, how the router will calculate the data bytes in a fragment, उसके लिए आपके पास सिंपल मेथड है, क्योंकि राउटर के पास क्या है, हेडर इंफॉर्मेशन है, और हेडर में आपके पास एक फील्ड है एंड दैट इज हेडर लेंथ. Header length, when you multiply it by the 4, you will get the actual header size, and in this case we have 20 bytes of header. That means header length value would be 5, and 5 for every fragment is having 20 bytes of header. So that's why यहाँ पे हम हर केस में कह सकते हैं कि हेडर लेंथ वैल्यू हमारी क्या होगी, 5. Got it? Now there is another field which is the total length, or you can say the length of or size of the packet, and the total length would be this, and if I subtract the header length or actual header length, okay, और एक्चुअल हेडर साइज अगर मैं उसमें से सब्ट्रैक्ट कर दूंगा तो बाकी जो बचा वो मेरे पास क्या होगा, डेटा बाइट्स होंगी. ओके, सो दिस इज हाउ द राउटर विल कैलकुलेट द साइज ऑफ डेटा इन अ फ्रेगमेंट. सो यहाँ पे अगर हम हेडर लेंथ की बात करें, सॉरी हेडर लेंथ हमने कैलकुलेट किया, हेडर लेंथ फील्ड में वैल्यू 5 होगी. व्हेन वी मल्टीप्लाई इट बाय 4 वी विल गेट द एक्चुअल हेडर लेंथ एंड दैट इज 20. टोटल लेंथ की अगर हम बात करें तो टोटल लेंथ यहाँ पे आप देख सकते हैं, दैट वुड बी स्टोर इन द हेडर इन इन द टोटल फील्ड, टोटल लेंथ फील्ड, ओके, इनसाइड द हेडर. Here you can see the total size or total length would be 180 plus 20, and that is 200. Here also the total length would be 200. Here you can see the total length would be 160, and here the total length would be 80 plus 20, that is 100. Here also 80 plus 20, that is 100. Here also, here we have 20 plus 20, that is 40. And if we talk about the total length here, that is 80 plus 20, that is 100. Here 60 plus 20, that is 80. So this is what the other field. Now if we how the we are going to calculate the number of bytes ahead. So for that we have to calculate the data byte inside the fragment, and we can calculate, I'm repeating once again, हेडर फील्ड में आपके पास दो वैल्यूज हैं, वन इज हेडर लेंथ और अनदर वन इज टोटल लेंथ. व्हेन यू मल्टीप्लाई हेडर लेंथ बाय 4 you will get the actual header length or actual header size, and when we subtract this actual header size from the total length, you will get the data size. Okay, so here in our for example, let's take this example. So here 20 bytes of header and the total length is 200. Okay, so that means the data bytes are nothing but 180. Okay, so this is how we can, the router will calculate the size of data in a fragment, and this is how we will calculate how many data is being ahead of that current fragment. Okay, now further there is a question कि क्या ये final solution है fragmentation में हमारे पास? So the answer is no. Why it is? Because we have to check whether this offset is sufficient. Okay. uh, Let me further clear one thing. यहाँ पे पहले एक बार देखिए कि मान लीजिए एक बार को ये मान के चलते हैं कि दिस इज द फाइनल सॉल्यूशन. सो रिसीवर के पास कितने फ्रेगमेंट मिलेंगे इन टोटल? फ्रेगमेंट 1. ओके, with offset value 0. Then this fragment is further divided into 3 fragments and offsets value are 180, 260 and 340. Then this last fragment is also further divided in 2 parts, which is having the offset value 360 and 440. So how many fragments we have received? 1, 2, 3, 4, 5, 6. So in total we have received 6 fragments. Now यहाँ पे रिसीवर को अगर ये 6 फ्रेगमेंट मिल जाते हैं, पहली बात तो रिसीवर को ये किसी भी ऑर्डर में मिल सकते हैं, बिकॉज डेटाग्राम की जब हम बात करते हैं, सो डेटाग्राम कैन बी रिसीव्ड आउट ऑफ ऑर्डर. सो हो सकता है कि पहले ये वाला ना रिसीव होके पहले हमें 260 वाला रिसीव हो रहा हो, ठीक है, फिर 440 वाला रिसीव हो रहा हो. मान लीजिए मुझे फर्स्ट रिसीव हो गया है और मुझे लाइक 340 रिसीव हो गया, 360 रिसीव हो गया, 440 रिसीव हो गया, बट मुझे 260 वाला रिसीव नहीं हुआ है. ओके, सो इन दैट केस हाउ द रिसीवर इज गोइंग टू फाइंड दैट? द सिंपल मेथड वाज कि हमें ये इन ऑर्डर आउट ऑफ ऑर्डर अगर मिले हैं तो हम सबसे पहले क्या करें, उनको असेंडिंग ऑर्डर में जमा लें. असेंडिंग ऑर्डर में हम जब जमा लेंगे तो हमें सीधे सीधे ये सीक्वेंस में लग जाएंगे. दैट इज फाइन, परफेक्टली फाइन. बट क्या केवल असेंडिंग ऑर्डर में जमाने से हमारा काम चल रहा है? हमारा काम इसलिए नहीं चल पाएगा क्योंकि यहाँ पे ऐसा हो सकता है कि कोई एक फ्रेगमेंट उसमें से मिसिंग हो, और अगर फिर भी हमने असेंडिंग ऑर्डर में जमा के किया तो यहाँ पे ये वाला पार्ट इसमें मिसिंग रह जाएगा. ओके, सो इवन देन दिस इज नॉट गोइंग टू वर्क हियर. how how this is going to be checked at the receiver end? रिसीवर इस चीज को कैसे चेक करेगा? थिंक अबाउट इट. कैसे कैसे इस चीज को केटर करेगा कि कोई कोई भी फ्रेगमेंट यहाँ पे मिसिंग ना हुआ? Are you getting my point? What I'm trying to say? I'm trying to say when, let's say, in case when offset was a sequence number like 0, 1, 2, 3, 4, okay, 5, like this, when the offset number was like this, so we can directly say if any number is missing, we can say that it is not complete and we should not combine over here. बट जब यहाँ पे कोई भी रैंडम नंबर हैं, सो उनको हम कैसे कैलकुलेट करें कि कौन सा मिसिंग है? असेंडिंग ऑर्डर में हमारे पास ये नंबर हैं. ओके, असेंडिंग ऑर्डर में रिसीवर ने उनको जमा लिया है और उस ऑर्डर में अगर वो उनको मिलाता है तो इट शुड मेक अ टोटल फ्रेगमेंट. ओके, कंप्लीट पैकेट, कंप्लीट डेटाग्राम में बन जाना चाहिए. बट यहाँ पे क्वेश्चन ये था कि इसमें से अगर कोई भी एक मिस हो गया, मान लीजिए दिस 260 इज मिसिंग, then also receiver is going to arrange in the rest of number in ascending order, और ascending order में जमाने के बाद उसको लगेगा everything is right and he is going to combine. वो ये मान के चलेगा there are 5 fragment and 0, 180 and then 340 and then 360 and 440, because by looking at this is the first fragment, by looking at the offset value में इसकी offset value में उसको पता लगेगा कि there is no bytes ahead of no data byte ahead of this, so this would be the first fragment. And by looking at the mf field he will get to know this is the last fragment, इसके बाद कोई और fragment नहीं है. इस बीच का अगर कोई भी मिसिंग हो जाता है तो देर इज नो पॉइंट कि रिसीवर उसको चेक कर पाएगा इस मेथड में. तो सो हाउ द रिसीवर इज गोइंग टू चेक दिस? if receiver use the data byte along with this offset value. So see what what is actually happening. So once the first byte is received, first fragment is received, receiver will add up the data bytes, that is 180, okay, and we'll see that next packet should receive with the offset value 180, okay, and then once he received 180 he will see the data byte, okay, and that is 180, and he will add the data byte to the offset, and that will make sorry, यहाँ पे ये further divide हुआ है, so first उसको ये second number पे उसको ये मिला होगा, okay, and after receiving this the data of this fragment is 80, so he will add up 180 plus 80 and he will be expecting 260 next. So once he receive 260 he will be add up 260 plus 80 and then he will be expecting 340 next, and once he receive 340 he will be add up 20 bytes over here, and the next would be 360, and once he receive this 360 fragment once he receive the fragment with offset value 360 he will add up 80 and the next would be 440, and by looking at the mf field he will get to know this is the last fragment, and hence this is the complete part जो आपको receiver इसको solve कर लेगा. नाउ माय क्वेश्चन इज कि क्या ये सफिशिएंट है, यहाँ तक हमारा सॉल्यूशन फाइनल है या इज देयर एनीथिंग लेफ्ट. सो देयर इज समथिंग लेफ्ट ओवर हियर एंड विच इज you must note here that the offset field is a 13-bit field, and that means the maximum value that it can have is 2 raised to power 13 minus 1, okay, and let us suppose the worst case of the fragmentation where the maximum size of fragment or maximum size of datagram is being fragmented. So let's say this is maximum total length maximum total length can be 65535, out of his 20 bytes is data and 65515 is the data. So let's suppose this datagram is being fragmented into many parts, okay, and in the worst case what actually going to happen if it is fragmented into many parts, then the last fragment will have the data size equal to 1. Okay, this is the worst case possible. Okay, you can think about it. Now once we can see if the last fragment is having the data byte size is 1, that means how many data is ahead of this. So offset value for this last fragment would be 65514, and that is approximate to 2 raised to power 16. Okay, so now that means we cannot store this 65514 value offset value in a field of 13 bit. That is the problem here. So what we can do over here, we can again do some scaling over here, and 2 raised to power 16 is the worst case size of offset, and we have maximum size that can be 2 raised to power 13, and that is we have to divide the offset value by 8. So if we divide every offset value by 8, that is 2 raised to power 3, so if we divide it by 2 raised to power 3, that will come out under 2 raised to power 13, and we can now store it. Okay, so every offset value should be divided by 8. Now that means here the offset value should be divided by 8, this offset value should also be divided by 8, this should also be divided by 8, Similarly here also it should be divided by 8, divided by 8, divided by 8, and here also it should be divided by 8, it should also be divided by 8. Now you can see that 0 divided by 8 is 0, so I am writing offset value 0. Now 180 divided by 8 is, so it is 22.5. So now again we found a problem here, that we found a decimal value of offset, and this decimal value again we cannot put into a fixed set notation. Okay, so now what we can do, so just remember what we have done in the header length part. When a header length of 30 byte, okay, and the header length value come out to be 7.5. So what we did, we add some extra bytes, that is padding, but that was to header. But here we are talking about the data. So now can we add some more bytes to this? Because now this 180 by 8 is coming out because of the ahead of bytes were 180 and we have divided by 8. So can we do some more, can we add some more bytes to this? We cannot add some more bytes to it because the MTU size is maximum over here, that is 180 plus 20, and that is equal to 200. So we cannot add more bytes to this fragment, but if we cannot add, what we can do, we can subtract. Okay, so what we have to do, offset value should be coming out to be, that is divisible by 8, that should be fully divisible by 8. So agar wo 8 से fully divisible है, in that case we will get the integer value over here. Okay, so that means we have to divide the data values in such a way that it should be divisible by 8, because once we are dividing 180 by 8 it is coming to be a decimal value. So now अभी हम क्या करेंगे, इसको हम बढ़ा नहीं सकते हैं तो हम इसको थोड़ा सा कम करके देखते हैं. कम कितना करें कि जो कि डिविजिबल बाय 8 होगा. सो द जस्ट बिलो वैल्यू which is divisible by 8 would be 176. Okay, so now the data bytes ahead of this is 176 and offset value would be 176 by 8, and that is 22. Okay, so here the offset value is coming out to be 22. Similarly, here also the data bytes, here also if we can see that there are there are data bytes ahead of this is 176, and there are how many data bytes ahead of this is nothing but 176 plus 180. Okay, and 176 plus 180, या फिर आप यहाँ से देख लीजिए कि this 368 is, this 180 is not also going to divide, okay, by 8. 176 is now divisible by 8, but we have to do 180, okay, to calculate the data byte ahead of this. And if we divide by 8, so 176 will be fully divisible by 8, but this 180 is not going to divisible by 8. So hence we have to change this value also, and we have to decrease this value also. So what we have to make, we have to make this value also 176. Now if we make 176 and 176 in total, that would be 4 and 4, 8 is being minus from here, so 352. So the value coming out to be 352 divided by 8, and that is 44. So 352 divided by 8 is 44. So yes, you can see now you can see how many how much data is there, 176, and here also it is 176. Now how much data should be increased over here, and so the last byte, last fragment should have 148 to make it 500. 176 plus 176, and what is the data left is 148. So this is how we can calculate. Now we have seen, just look at here, what is going to happen over here. And before looking over here, we have to see what are the other fields that are going to change. So here MF field is not going to change, that is going to remain same. Header length field is going to remain same because the header size is same. The total length is going to vary now. So the total length now will be 176 plus 20, that is 196. Here also this will become 196, and here the total length field will be 148 plus 20, that is 168. Okay, now coming to this, how about the offset of this? So this is also going to change because we have changed the value over here. So now the data bytes ahead of this are nothing but 176, and 176 divided by 8 is 22. So this is going to be same, either you can take the value directly from the parent, which is here it is. So the first fragment after refragment will have the same value of offset what the parent has. So that would be 22, और you can understand in this manner कि इस fragment से कितने डेटा बाइट इससे आगे हैं. So those were 176 data bytes are ahead of this fragment. Okay, and if we divide it by 176 by 8, we will get 22 as offset value. Now 176 plus 80, 176 plus 80 is the data byte ahead of this fragment. This fragment, if we talk about this, so for from this fragment, how much data byte are ahead of? So those are 176 plus 80 bytes of this fragment. So that would be 6 256. So here I can write 256 divided by 8, and 256 divided by 8 is 32. So here it is coming out to be, offset value is coming out to be 32. Now how many data bytes are ahead of this? So you can see there are 176 plus 80, which is 256, and plus 80. So if we make 256 plus 80, that would be 6 336, and 336 divided by 8, 42. So here it is coming out to be 42. Now we have to see this 176 is further divided into 80, 80, and how much is left? 80, 80 is 160, and then 16 is left. So the last data is going to change with 16. Okay, so now this is total 176. So we can say this fragment is further divided into these three fragments. Okay, now what are the values that are going to change? Again, MF is not going to change. HEL, that is header length value, is not going to change because header size is same. Total length now is going to change, and in this case it is same 100. In this case it is same 100. In this case it is going to be 36. So this is going to change, and this will become 36. Okay, now how about this? when the last fragment is further refragmented, you can see how many data bytes ahead of this, how many data bytes are ahead of this are similar to the data bytes ahead of this. So how many data bytes? 176 plus 176, because यहाँ पे भी data bytes को आप calculate करोगे तो ये 176 ही आएगा. So 176 plus 176 are nothing but 352. So here it is 352, and 352 divided by 8 will give you 44. So it is coming out to be 44. Similarly, how many data bytes ahead of this are nothing but you know 352 for this and 80 of this. So 352 plus 80, 432, and 432 when we divide by 8. So 432 divide when we divide by 8, 54. So it is coming out to be 54. Now the total field value here it is remain as 100, and the total size is 148 over here, and out of this 80 bytes can be placed in the first fragment. So how many data bytes are left? That is 68 are left. Okay. So now the fragment the total length field would be 68 plus 20, that is 88. Yes. Now this is something that we can say it is the final thing. Okay. This is how the fragmentation is being done. So first thing you have to see, there is one thing that I want to quote here, that till here we have seen whether this is divisible by 8, whether this was divisible by 8, whether this was divisible by 8, but we haven't seen whether this was divisible by 8. We have divided further into these two parts. So last byte here is 68. क्या इसके लिए भी हमें इसको यू नो 8 का मल्टीपल होना चाहिए? क्या 8 का मल्टीपल बनाने के लिए हमें इसको डिक्रीज या इंक्रीज करना चाहिए? So just because it is the last byte, so there is no offset further left जिस जो कि इससे अफेक्ट होने वाला है. ओके, इसके बाद कोई और फ्रेगमेंट तो है नहीं. सो जब और कोई फ्रेगमेंट आगे नहीं है तो वी कैन टेक दिस लास्ट fragment as it is, whether or not it is divisible by 8. So you can see here that 68 is not divisible by 8. Okay, but still we can have the value 68 over here and there is no problem. So this is the final answer for the fragmentation. Now we will see that how many data packets we have, or sorry, how many fragments we have received. So the receiver will receive in total 6 fragments with offset value 0, 22, 44, sorry, not 44 and not 22. So it will receive 0, and this is further divided into 3. So then 22, and then 32, and then 42, and after this is further divided into two parts, which is 44 and 54. So these are the fragments which the receiver will receive. इनको ascending order में वो जमाएगा. Ascending order में जमाने से केवल काम नहीं चलेगा. I told you the receiver has to calculate the data and he should add up the data, okay, to the offset, and then he will get to know whether any fragment is missing or not. So उसके लिए वो क्या करेगा? So he will simply see this is the first fragment because it is having the offset value 0. So definitely there are no bytes ahead of this. इससे पहले कोई भी नहीं है. So this would be the first fragment. ये first fragment उसको मिलेगा. इस first fragment की आपके पास जो offset value है that is 0 and the data bytes in this fragment is 176. So he will add up 176 to this. Okay, and he will see if the total is 176, so he will divide it by 8 and will see what would be the output, and that is 22. So he will wait for the next fragment of with offset value 22. Okay, once he will receive this this fragment, he will calculate the data byte further. Okay, so he will add up the data byte of this, okay, to previous, so which is 176 the previous one and 176 for this, and that would be you know uh, uh, 176 plus 176 would be 352. Okay, and 352 he will see sorry, yeah, he will receive this byte. Okay, so I just made a mistake. So he will receive, first he will receive this 0 and this 22 is for this fragment. Okay, so he will add up 176 plus 80 bytes for this and will divide by 8 and will check the next offset value. So this would be 22 and this will become 10. So this will give you 32. So the next fragment that it is waiting for is 32. Similarly, like this. So this is how the receiver is going to respond for the fragments. Now the total bytes, data bytes which was being sent was 500 bytes, and you can see over here that the data byte in this first fragment is 176, in this second fragment is 80, in the third fragment it is 80, in the fourth fragment it is 16, in the fifth fragment it is 80, and in the sixth fragment it is 68. So if you add all of these, okay, you can see, you try to add. So 176 plus 80 plus 80 plus 16 plus 80 plus 68, and that would be. So this is coming out to be 500 bytes. So the data bytes are not going to differ in the fragmentation. We will receive the same data byte what it is being sent, because we have divided this data into multiple fragments. Okay, but the total size is going to differ because we are having more number of headers. Here it was there was only one header, but now we have received 6 fragments, so we will have 6 into 20, which is 120 bytes extra for this header. So previously it was, if you want to see the overhead, so previously there was one header and then now we have 6 headers extra, 6 headers. So that means in total 5 header extra overhead would be there. So 5 into 20, which is 100 bytes of overhead, he will the network will face. So network में आपके पास overhead कितना हुआ fragmentation की वजह से, particularly in this particular example, and that is 100 bytes. Now we can calculate the efficiency and efficiency is nothing but useful byte divided by total bytes, and here in our case we have the useful byte is 500 and the total byte are nothing but 500 plus 120, that is 620. So it is 500 divided by 620. So that would be the efficiency of the network layer when we have done the fragmentation. Now if we talk about the throughput, so throughput would be utilization or efficiency into bandwidth. Sometimes we call that throughput as bandwidth utilization. So bandwidth utilization is nothing but the throughput, and that is efficiency into bandwidth. So we have calculated the efficiency and bandwidth will be given to you, and that is how you can calculate the throughput. There is one thing that I want to quote here is when you are trying to find out the bandwidth, you have to take the bottleneck bandwidth or the minimum bandwidth given in every network. So you have to take the minimum of bandwidth that is present. For example, let's say we have network like this and we have source over here and we have one router and there is other network, and let's say we have again one router and let's say we have this network. So suppose the bandwidth provided over here is 1 Mbps, here it is 2 Mbps, here it is 3 Mbps. So just because we can be sure about that 1 Mbps if we provide as bandwidth, that can be utilized in every network. Okay, so here for this particular example, in case of calculating the throughput or bandwidth utilization, you have to multiply efficiency by 1 Mbps. Okay, so that is the case.